Do you remember inverse functions? Say I have f of x equals x squared plus 1. To find the inverse function, we said 1, f of x becomes y. 2, then we had to switch x and y. Remember, that's not just one x and y, that's all x's and all y's, so that our domain becomes our range and our range becomes our domain. 3, we're going to solve for y, which is sort of like a new y, and our fourth step was that y now becomes f inverse of x. It looks like f negative 1 of x. So if we are given f of x equals x squared plus 1, well, is that a function? Here's what it looks like. It's our y equals x squared function, but moved up 1. Does this pass the vertical line test? Sure it does. So it is a function. We can use functional notation. So f of x becomes y, and then we switch x and y, and now we're going to solve for y. Subtract 1 from both sides. Y squared is equal to x minus 1. So y is equal to plus or minus the square root of x minus 1. And that is our inverse function. So here are our results. The function was x squared plus 1. The inverse function was plus or minus the square root of x minus 1. And so when we graph this, we get this U shape, but moved up 1. And we said it was a function because it passed the vertical line test. But it fails the horizontal line test. And therefore, it doesn't have an inverse function. Of course it doesn't. If we graphed this function, or I'm sorry, this is a relation, we get this. And so we remember, if the original doesn't pass the horizontal line test, then its inverse does not pass the vertical line test. So this is not a function. This inverse is not a function because the original graph did not pass the horizontal line test. So how are we going to get around that? Well, let's limit the domain here so that this passes the horizontal line test. If we make our domain from 0 to infinity, then we only get this half of the graph. And that means this part is gone. So here we're going to have our graph. Now, if this is the point 1, then our range starts at 1 and goes to infinity. That's the y values. We're starting at 1 and going to our infinity. And our x goes from 0 to infinity. Now, if we graph this and its inverse, we're going to get this shape here. And this one goes away. So remember what we said, the domain becomes the range and the range becomes the domain. So our domain and range are easy to find. Our range becomes the domain. We're going from 1 to infinity with the x. Well, look at this point. It's 1, 0. So we are going from 1 to infinity. And our domain becomes the range. So whatever's here is going to go here. And is it true, the range, the y values go from 0 to infinity? Yes. Notice what's happened here. This was our point 0, 1. Notice the point 0, 1 became the point 1, 0. If I put in a 1 here, 1 squared is 1 plus 1 is 2. So I get the point 1, 2. That means that the point 2, 1 will be over here. And you can see, because this passes both the horizontal and vertical line test, then we're going to have an inverse function. Any point over here, this was our big takeaway, AB becomes the point over here, BA. We're just switching x and y. One final thought on this sort of pre-class to the logarithmic function. When we have x squared plus 1 with a restricted domain, it passes both the horizontal line test and the vertical line test. When we say that a function passes the horizontal line test, it is a one-to-one function. Remember, only one-to-one functions have inverses. One-to-one functions pass the horizontal line test, and they have only one y value for each x value. It's a one-to-one function.